everyone and welcome back to our channel. This is video 2 of our ongoing MCQ video series. I hope you have already watched video 4, 5 and 6 because this MCQ series is based on the concepts covered in these 3 videos. Question number 1. A manufacturer wants read-only memory that can be erased and reprogrammed using ultraviolet light exposure. Which type of ROM should they use? Go through the options and think of the answer. The right answer is option number C, EEPROM, which stands for Erasable Programmable ROM. It can be erased using UV light and reprogrammed. I hope you remember the rest of the ROMs. If not, I will tell you after you answer this question. Question number 2. Which of the following is true? Go through all the statements. It is a comparison between PROM and mask ROM. The right answer is option number A. What is mask ROM? Mask ROM is programmed permanently at manufacture. It cannot be rewritten. On the other hand, PROM stands for programmable ROM. It can be programmed only once using special device. It cannot be changed after that. EEPROM we have already discussed can be programmed using UV light, and EEPROM is electrically erasable programmable ROM. It can be erased and reprogrammed electrically. Question number 3 is which of the following is true? You can expect 10 or 15 questions like these. Multiple statements are given and you have to tell which of the following are true. If you know the topic well, you will be able to easily answer this. The right answer is option number D, only A and C. SRAM is static RAM. It uses flip-flop made of transistors that hold data without needing periodic refreshing. Since it does not needs to be refreshed, it is faster, it is used for cache memory and also it is expensive. DRAM is dynamic RAM. It stores data as charge in capacitors that must be refreshed. That is why it is slower and it is used as main system RAM. Therefore, statement 1 and 3 are correct. Question number 4. Which type of memory loses its stored data when the power supply is switched off? Very simple. The right answer is option number B, RAM. ROM, HDD, SSD are all non-volatile. RAM is volatile. Question number 5. ROM is primarily used in computers to store. The right answer is option C. ROM is non-volatile and typically stores permanently, rarely changing instructions like firmware such as BIOS. Question number 6. Why do SSDs generally outperform HDDs in terms of read-write speed and reliability? The right answer is option D. SSD stores data electronically using flash memory, whereas HDD store data magnetically on spinning circular disk called platter. A mechanical read-write head moves across the platter to access data, and therefore HDD is slower compared to SSD. Question number 7. In a typical modern CPU cache hierarchy, why is L1 cache smaller in size than L2 and L3? The right answer is option number D. Smaller size allows L1 to be built closer to the CPU core, minimizing access latency. Its size is in KBs and it is the fastest, whereas L2 is larger than L1 and L3 is the largest. Question number 8. Virtual memory allows a computer to run programs larger than its physical RAM by. The right answer is option A. What is virtual memory technique? It is a technique where operating system uses portion of secondary storage as if it were additional RAM. It allows system to run larger programs or more programs simultaneously. Question number 9. Which storage medium provides only sequential access, not random access, and is mainly used for large-scale data backup archival? The right answer is option C, magnetic tape. Magnetic tape has sequential access only. It does not have random access, and that is why it is the slowest of all. Question number 10. Which of the following is not a core function of an operating system? The right answer is option C. Compiling source code is performed generally by a compiler, which is an application software running on top of operating system. Question number 11. The technique of dividing CPU time into small slices distributed among multiple users or tasks in rotation is known as. The right answer is option C. What is multiprocessing? It is two or more CPUs or cores actually executing instructions simultaneously. It is a genuine parallel execution, not switching. Whereas time sharing is a technique that enables multitasking in which CPU time is divided into small slices and distributed among multiple users or tasks. Question number 12. Which operating system designed to process data and respond within a strict guaranteed time limit in which missing a deadline is strict failure? The right answer is option B, a hard real time operating system. It is a system designed to process data and respond within a strict guaranteed timeline. Missing a deadline can result in total system failure. Example, airbag control system. Whereas, what is a soft real time operating system? A soft real time operating system is designed to process data and respond within a specified time, but missing a deadline degrades performance without causing system failure. So that is the difference between hard real time and soft real time operating system. Question number 13. What is the fundamental difference between multiprogramming and multitasking? The right answer is option C. Important terminologies. Multiprogramming keeps multiple programs in memory but switches when one is waiting, while multitasking allows rapid switching to improve user experience, and multitasking use fast time slice technique. Question number 14. In CPU scheduling, what does burst time refer to? Right answer is option B. Burst time is the amount of CPU time a process requires to complete its execution. Example, if process 1 requires 2 minutes of CPU time to execute, its burst time is 2 minutes. Question number 15. Under FCFS scheduling, what major drawback can occur when a long process arrives before several short processes? The right answer is option C, convoy effect. FCFS is a CPU scheduling algorithm in which processes are executed strictly in the order in which they arrive. First come, first serve. So, if a long process arrives first, it will execute first, and all the shorter processes behind it must wait. Even though they could finish much faster individually, but they will have to wait. And this is the convoy effect. Question number 16. What is a major practical limitation of the non preemptive SDF scheduling algorithm? The right answer is option A. So, what is SDF or shortest job first? It is a CPU scheduling algorithm that selects the process with the shortest execution time. So, for example, if P1 arrives at 0 minutes and has a burst time of 10 minutes, and P2 arrives at first minute and has a burst time of 1 minute. Since P1 is the only process available at 0th minute, the scheduler starts executing P1. It continues executing P1 for 10 minutes, even though P2 requires only 1 minute and has arrived at the first minute also. Therefore, P2 has to wait until P1 finishes, and that is the limitation. Short job first requires advanced knowledge or an accurate estimate of the burst time of processes in order to schedule them effectively. Question number 17. Process A has arrival time of 2 millisecond, completion time of 10 millisecond, and burst time of 5 millisecond. What is its turnaround time? The right answer is option C, 8 millisecond. Turnaround time is total time from arrival to completion, and therefore it is calculated as completion time minus arrival time. So simple maths. 10 minus 2 is 8. Question number 18. Which type of operating system manages multiple independent physically separate computers so that they appear to the user as a single unified system? The right answer is option C. Distributed OS manages a group of independent physically separate computers and makes them appear to the user as a single unified system. Network operating system runs on a server and manages network resources. Here, the user is fully aware that there are separate systems on the network. In a batch operating system, jobs are collected into a batch and processed one after another with no direct user interaction during execution. And time sharing operating system allows multiple users to use the same computer system simultaneously by dividing the CPU time into small time slices. Question number 19. In round robin scheduling, what determines how long a process executes before being preempted? The right answer is option A. In round robin scheduling, each process gets a fixed small unit of CPU time called time quantum in rotation. When the time quantum of the current process expires, the CPU is given to the next process in the queue. And this process continues in the same way, going around the queue repeatedly until all the processes are completed. Question number 20. A process that is loaded into memory and waiting for CPU time but is not currently executing is in which state? The right answer is option C, ready state. In ready state, a process is loaded into memory and waiting for CPU time so that it can execute. Whereas what is waiting state? It is a state in which a process is paused because it is waiting for some event or resource before it can continue. Question number 21. Which scheduling algorithm is most likely to cause starvation of long processes if short processes keep arriving continuously? The right answer is option A, SRTF or shortest remaining time first. It is the preemptive version of shortest job first scheduling algorithm. It always favors the processes with shortest remaining execution time. Therefore, long processes may have to wait for a long time, increasing their chances of starvation. In FCFS, the job that arrives first get executed first. In round robin, each process gets CPU time in rotation. In multi-level queue scheduling, the queue is split into multiple separate queues and each queue has its own scheduling algorithm. And in priority scheduling, each process is assigned a priority number and the CPU is given to the highest priority process first. Question number 22. Which of the following is not one of the four necessary conditions for deadlock? The right answer is option E, none of these. No preemption, mutual exclusion, hold and wait, circular wait are all necessary conditions for deadlock. All of these four conditions must be present for a deadlock to occur. Question number 23. What does the mutual exclusion condition for deadlock mean? And the right answer is option C. It means that at least one resource must be held in a non shareable mode such that only one process can use it at a time. Question number 24. Which of the following is true for deadlock avoidance and deadlock prevention? And the right answer is option A. Deadlock avoidance dynamically examines the resource allocation state before granting a request, whereas prevention restricts how requests can be made by denying one of the four necessary conditions for deadlock. Option B says deadlock avoidance and prevention are used interchangeably. It is not right. Deadlock avoidance only works after a deadlock has already occurred, whereas prevention prevents deadlock to happen. No. Avoidance works before deadlock occurs and not after. Deadlock prevention requires advanced knowledge of future requests? No. It is generally deadlock avoidance that require information about future needs, such as maximum resources required. Deadlock prevention uses Banker's algorithm to avoid deadlock, whereas deadlock avoidance ensures system remains in a safe state. Banker's algorithm is used in deadlock avoidance and not in prevention. And therefore, all the options are wrongly stated, and option A exactly tells the difference. Question number 25. One strategy to prevent deadlock is denying hold and wait. How can this be practically implemented? The right answer is option D. A hold and wait condition means that a process is holding at least one resource while simultaneously waiting to acquire additional resource. To prevent this condition, a process can be required to request all the resources it will ever need before it begins execution. If all the required resources are available, they are allocated to the process upfront. The process then does not hold some resources while waiting for others. Therefore, option D is the right answer. Question number 26. In a resource allocation graph, what does a directed edge from a process P to a resource R indicate? The right answer is option A. A directed edge from a process P to a resource R indicate that process P has requested resource R and is waiting for it to be allocated. It is also called a request edge. Whereas, what is an assignment edge? An arrow pointing from a resource to a process. It means that resource has been allocated to that process. Question number 27. What is a race condition in the context of process synchronization? The right answer is option E. A race condition occurs when two or more processes access and modify shared data concurrently, and the final result depends on the timing or order in which their execution steps occur. Question number 28. In the critical section problem, what does the progress requirement ensure? The right answer is option B. A solution to the critical section problem must satisfy three conditions. First is mutual exclusion, second is progress, third is bounded waiting. What is the meaning of progress? It means that if no process is currently in the critical section, the decision of which waiting process should enter next must not be postponed indefinitely. It ensures that waiting processes eventually get a chance to enter the critical section. Question number 29. How does a binary semaphore differ conceptually from a mutex? The right answer is option C. Both mutex and semaphore are synchronization mechanisms used to control access to critical section and shared resources. A binary semaphore can have two states, 0 and 1. Unlike a mutex, it does not have ownership. The process or thread that acquires the semaphore does not necessarily have to be the one that releases it. Whereas in a mutex, the thread that locks the mutex becomes its owner, and only that specific thread is allowed to unlock it. So that is the difference between these two. Question number 30. Which statement is true? The right answer is option A. In deadlock detection and recovery, the system allows deadlock to potentially occur but periodically checks for it and recover it if one of it is found. The second option, deadlock detection design the system so that at least one of the four necessary conditions of deadlock can never occur. This is actually deadlock prevention. Deadlock detection carefully analyzes each resource request before granting it to ensure the system remains in a safe state. This is deadlock avoidance. Deadlock detection is only applicable to a single process system. This is not right. Deadlock detection is applied only during system boot up and never afterward is also not correct. So, a last bonus question. What do the wait and signal operations do when used with a semaphore? The right answer is option A. The wait signal decreases the semaphore value. If it goes negative, the process is blocked. And signal operation increases the semaphore value, potentially unblocking a waiting process. So that was all for today's video. If you have already watched video 4, 5 and 6, you should be able to answer all these questions correctly. However, if you got some questions wrong, I recommend going back and watching all the videos and revising the concepts again so that you don't make the same mistake in the exam. If you gain some insight from this video, please give us a like. If you have any queries, let me know in the comment section. And if you haven't subscribed the channel yet, please do it so that you do not miss any upcoming video. Thank you so much and keep watching Array.